Alkenes are hydrocarbons and their molecular formula is CnH2n. The DBE of the alkene, assuming that the alkene has only one double bond, is equal to 1. But keep in mind that every double bond has a DBE of 1. So if the alkene has more than one double bond, the DBE is going to be the sum of its double bonds. All alkenes are water insoluble, and the only type of intermolecular forces in the alkene is the van der Waals forces. If you look at the alkene, which is the carbon double bond carbon, the pi bond is the overlap of the two p orbitals. So the pi bond is going to act as a nucleophile every single time. So if you have an electrophile in the solution, the double bond is going to open up to pick up the electrophile. Now, groups around the alkene can either be arranged to be on the same side or they can be on opposite sides. Normally, we use the term cis and trans whenever we have two groups that are the same. And these groups that are the same are either on the same side or they are on opposite sides. Here in this example, you can go either by the hydrogens or by the CH3s. As long as you have two groups that are the same, you can use the cis and the trans. Now, to name the alkene, always choose the longest carbon chain that includes the double bond and give the double bond the lowest number possible. If you start numbering from one carbon of the double bond, continue and number the second carbon in there and make sure that your double bonds are included in the longest carbon chain. So you're going to name this as a chain of 4 carbons. It's going to be butane. You drop the A and E and you put an E and E. And then you label where your double bond is. So that is going to be 2-butene. If there's a stereochemistry around the double bond, you have to label that as cis or trans. Now remember that cis and trans, these are geometrical stereoisomers. And if there is a chiral center, then it will be a diastereoisomer. So you cannot go from cis to trans by a simple rotation. Stereochemistry also exists if you have 3 or more groups, different groups around the alkene. In this case, you cannot use the cis and trans, you will use the E and the Z. So in order to locate the E and Z, first of all, you have to locate your double bond and divide your double bond in half, and then look at each carbon separate. So start by looking at, for example, this carbon over here and set your priorities. So we have a carbon and we have a bromine. Bromine has a higher priority. So your higher priority is located in this position, which is down. And here the higher priority is located up. The priorities are opposite to each other. So this is E. So E, it means a trans and Z means cis. So when the priorities are on the same side, then this means that it is a Z. Every time you have a chance to have stereochemistry around the alkene, this is going to be included in the name. Choose your longest carbon chain and give your double bond the lowest number. After you give your double bond the lowest number, then if there's a possibility to give the substituent the lowest number, then go ahead and do that. Here I can number the double bonds from either one of the sides and it will be number 2. So this is why I go by the route to give the substituent the lowest number. I have to locate that on 2 my double bond starts, and it's that double bond which has a Z stereochemistry. If you have more than one double bond, then you are going to use the prefix di in front of the ene, and every double bond needs to have a number. And if there's a stereochemistry around the double bond, you have to include those as well. So for example, here, the substituents around the double bond, they are on the same side. For this double bond, they are on the same side. And your double bonds, they do start on carbon number 2 and on carbon number 4. So this is why on carbon number 2 you have a Z stereochemistry, on 4 you have Z stereochemistry. You separate those by commas. Another example here, always choose your longest carbon chain that has the double bond. So here my longest carbon chain is 1, 2, 3, 4, and 5. You cannot do the longest carbon chain and exclude the double bond. So the double bond has to be in the longest carbon chain, and start numbering to give your double bond the lowest number. Here around the double bond, I don't have a stereochemistry because I do have two groups that are the same. I have a hydrogen here and the hydrogen here. So the moment you have two groups that are the same on the same carbon, you will not have a stereochemistry around this carbon. So to name this is going to be 2-propyl. And then I know that my double bond is on carbon number 1, so you can skip that. And this is going to be pentene. You don't have to say 1-pentene. This is another example over here. I'm going to start numbering from, or I'm going to start my longest carbon chain from the double bond, and you include all the double bonds, even though if, let's say, for example, your chain including the double bonds is shorter than any regular chain, or you can get more carbons if you skip the double bonds, don't do that. Always make sure to include all the double bonds in your chain, and start numbering to give the first double bond the lowest number, and then the substituents. So this means that I need to start numbering from this double bond here. This is a 3, 4, 5, 6, 7, 8, 9, and 10 in there. So I have a double bond at carbon number 1. I have a double bond at carbon number 5. This is when the double bond starts. And I have a double bond on carbon number 9. So double bonds on carbons 1 and 9, they don't have stereochemistry because there are two groups that are the same on these two carbons. But the double bond on 5, yes, there is a stereochemistry, and you can easily see that the groups are trans or they are E. You can use both. You can use a trans or you can use E. Normally in naming, we prefer to use the E and the Z system over the trans and the cis, but you can still use the trans and the cis since also you have two hydrogens that are the same here. And the rule for cis and trans, you can use those if you have two groups that are the same. So here I do have 5 E between parentheses, and then I'm going to put a dash, and then you're going to do the name in there. My longest chain is going to be decatriene, and then on carbons 2, 5, and 9, my double bond, and on carbons 2 and 8, I do have my dimethyl, and then 2, 5, and 9, this is deca tri-ene. So I have 3 double bonds, and this is the tri, and every double bond has a number, okay? And only one of these double bonds, because it's the double bond number 5, on carbon number 5, that shows a stereochemistry. This means that the other double bonds are terminal. Okay, now here again, choose the longest carbon chain and start by giving your double bond the lowest number. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Isopropyl is not an IUPAC name. Isopropyl is a common name. You can still use it in IUPAC if the given allows you to do so. The IUPAC name, this is going to be 1, 2, it's going to be 1-methyl and an ethyl in this case. Okay, so the name here is going to be 2-decene because your double bond is on 2. And I know that on 2, this is going to be an E, stereochemistry. And on 9, I do have my methoxy. And on 5, I do have my 1-methyl ethyl. Okay, so I do have my methyl and methoxy. Methoxy comes first, so this is going to be the 2E, 9-methoxy, and the 2-decene. And of course, there is a dash between the parentheses and the two. If the double bonds are part of the cycle, then make sure that to include all the double bonds in there, and your ending is going to end in the cycle. Give your double bonds the lowest number, and here in this case, I have two options. Either start numbering from this double bond or start numbering from this double bond. So if I start numbering from this double bond, then this is going to be 1, 4. And if I start numbering from this double bond, then this is going to be 1, 4. I'm going to get both same numbers in both ways. So what's going to determine which way I go with is the substituent. So if you look at the substituents over here, this is an ethyl and this is an ethyl and this is a methyl. So the E comes first. So this is why I have to start from this double bond. So starting from this double bond, we're going to go ahead and do 1, 2, 3, 4, 5, 6, 7, and 8. So the ending is going to be in 2, 4, cyclo, octa, diene. You have two double bonds, and this is the prefix di, and each double bond has a number. And then on the second carbon, you do have an ethyl group. And on carbon number 4, you do have a methyl group. For this example over here, choose your cycle that includes the double bond, but this is going to leave us with these substituents as a double bond that are coming off the cycle. So we're going to name them as substituents. If you have an alkene coming off the cycle of 2 carbons, this is called a vinyl group. Okay. If you have one alkene carbon coming off the cycle, this is called a methylene group. And then we know that this is a methyl group. You're going to start by giving your double bond the lowest number and the substituent also the lowest number. So the first substituent here that I have is this carbon over here that has the CH3 on it. So this is why I'm going to start numbering from this carbon. This is going to be carbon number 1. You go by carbon number 2. You cannot go by 1 here and then move to the second carbon and say this is 2, because these two carbons, they belong to the double bond. So you cannot number 1 without numbering the other. I started numbering from here to give the CH3 also the lowest number possible. And I am moving this way. This is going to be 2. That is going to be carbon number 3. This is going to be 4, and this is going to be 5. The name will be 1-methyl, 5-methylene, 3-vinyl, and cyclopentene. We can drop the 1 over here. Now let's say, for example, if we have that same structure there, but instead of the vinyl, we have an allyl group. So we have 1 carbon more between the double bond and the cycle. This is now called an allyl group in there. So in order to name this now here will be called an allyl group. And an allyl group is a group that has an alkene, and next to the alkene there is an sp3 hybrid carbon. We've talked about this before. So now your longest carbon chain is going to be the cycle. You cannot choose the double bond from the cycle and you go and you do the double bond from the chain. It's either the cycle or the chain. It's definitely going to be the cycle because the cycle has more carbons than that of the chain. This is why you choose the cycle. And the chain is going to be a substituent of the cycle. And then you're going to start by giving the double bond in the cycle the lowest number. So that is going to be 1, 2, and this is going to be 3. So now to name this is going to be 3-allyl. And then it's going to be cyclopentene. There are more problems posted in the extra problem set. Make sure that you work those out.